All right, so 11.1, which is the first lesson of Chapter 4. Chapter 4 is just 2 lessons or 3 lessons. It's short. So we're now going to begin a new investigation in which you will use your knowledge of chemical reactions, which are all those key concepts, to investigate to help police investigate a robbery. Read the new message from Dr. Young on the next slide. To student chemist from Dr. Samara Young, lead chemist. Subject: someone stole the Lafayette. How do you I should have practiced that one, huh? I know this word. It's a big fancy diamond, Lafayette diamond. There's been a robbery at the Westfield Museum. This morning, the museum staff discovered the rare and expensive diamond was missing. When police arrived, they found a hole that had been made in the glass display where the diamond was stored. Next to the display case, they found a plastic container that was half full with an unknown substance. Police think that the thief may have used some of the substance to make a hole in the glass and may have accidentally left the rest of the substance behind. The chief of police have asked me to help them identify this unknown substance and determine who could have used it to steal the diamond. As you have recent experience in working with the community of Westfield, I am turning the case over to you. I hope you remember what you have learned so far about chemical reactions. I think you will need to use your knowledge to help the police crack this case. So we're trying to figure out who might have used the unknown substance to steal the diamond. Let's review what we know. We know that the diamond thief used an unknown substance to make a hole in the glass. The diamond thief did not use all of the unknown substance. Some of the substance was left behind at the crime scene by accident. Before we can start to think about who might have committed this crime, we need to identify the unknown substance that was found at the crime scene. Officer Diaz investigated the crime scene. He observed the unknown substance and made these observations. It was a colorless liquid with a strong, irritating odor. So those are the physical properties of the substance. We're going to now go to Google Classroom and open up number 2. We're going to use slides 1 and 2 to identify the unknown substance, and then keep the slides open, but return here after slide 2. So Google Classroom. And number 2 for today. Identifying an unknown substance. The police have made a short list of substances they think could have been used to make a hole in the glass. All of these substances are corrosive, which means they can cause damage when they come into contact with substances such as glass. Examine the table below. Then use the strongest evidence from Officer Diaz's observations to help you determine which substance was used to make a hole in the glass. So go ahead and read through the substances and the properties. And remember that Officer Diaz said it was a colorless liquid with a strong, irritating odor. That's up on the board for you to refer to. Anyone have some thoughts? Sky, one? Hydrofluoric acid. Very good. Colorless, strong, irritating odors, liquid at room temperature. And what about the other one, Nathan?
Well, the other ones, or the other colorless one is odorless.
Oh, okay.
So it wouldn't be that one.
Okay, good. Yes, you are correct. I am sorry. I didn't catch that. I thought there was going to be 2. Great. So then we have hydrofluoric acid. So why does it have to be hydrofluoric acid? What key concept can we use to say that that has to be the correct one?
Because it has the same physical properties.
Right. Remember our key concept. Different substances have different properties. So same substances have the same properties, right? So that's how we figured out that it was hydrofluoric acid. So on here, you're going to type your answer and then explain and use a key concept from chapter 1 to support your answer. This is a link that will take you to the key concepts if you need that, or they're right on the backboard, or I just said it.
It's not letting me do it because I'm on Google.
You are the only, oh, you know what I did? That's what I was fixing, Nathan. I was deleting them all and putting new ones in.
Oh, okay, so I just had to open.
Yeah, you have to open up a new one. And I was just checking who was on there. It was you. Everyone else can type, right? I think I fixed it, yeah. So you should be saying hydrofluoric acid and then supporting that with a key concept from chapter 1. And then our directions told us to go back to the Nearpod after slide 2. So when you're finished, you're going to come back to the Nearpod. So as we said, we noticed that the properties of the hydrofluoric acid match Officer Diaz's observations. Okay. Now that the police know that the hydrofluoric acid was used at the crime scene, they have been looking for suspects who could have made the hydrofluoric acid. Police have identified 3 possible suspects who ordered suspicious substances from a local chemistry supply company and may have been able to produce this hydrofluoric acid. So we have Pat, Alex, and Tracy. Pat is a sculptor, and he ordered sulfuric acid and calcium fluoride. Alex is a gardener. He ordered sulfuric acid and magnesium chloride. And Tracy is a chemist. He ordered purified water and fluorine. Over the next few lessons, we're going to try to figure out which suspect most likely committed the crime. First, you're going to need some more information. Here's our 3 claims. Pat is most likely to have made the hydrofluoric acid using the sulfuric acid and calcium fluoride. Alex is most likely to have made it using the sulfuric acid and the magnesium chloride. Or Tracy is most likely to have made the hydrofluoric acid by using purified water and fluorine. We know the name and some of the properties of hydrofluoric acid, but we still don't know the groups of atoms that make up this substance. We need to know this information in order to determine whether or not any of the suspects could have made the hydrofluoric acid. We also need to know the groups of atoms that make up each of the substances that the suspects ordered. Just knowing the names of these substances isn't enough to determine if these substances could have been used to make the hydrofluoric acid, right? We have to see what those things are made up of. After you inform Dr. Young that the unknown substance is hydrofluoric acid, she sent a message with more information. You did a great job using the properties to identify the substance found at the crime scene as hydrofluoric acid. We are lucky that Officer Diaz provided detailed observations. Here is some additional information about hydrofluoric acid at the atomic scale. This may help you as you continue to investigate this case. So, hydrofluoric acid is a repeating group of atoms made up of hydrogen and fluorine. Now that we know that hydrofluoric acid is made up of repeating groups of hydrogen and fluorine atoms, we can use this information to think about which substances the suspects ordered could have been used as reactants to produce the hydrofluoric acid. Next, we're going to use the modeling tool to make models for the police that show whether or not each substance could have made the hydrofluoric acid. each suspect. I keep switching those two words. As you create your model, you're going to use the substance reference guide. This includes an atomic scale model of each of the substances the suspects ordered. So we're going to go back and we're going to read slides 3 and 4 and then complete the model on slide 6 and determine which of the suspects could have made the hydrofluoric acid. So we're back here, slide 3. The police want your help to decide if they should continue investigating the 3 suspects. Complete the modeling tool activity, making hydrofluoric acid to show the police whether or not each of the suspects could have produced hydrofluoric acid with the substances that they ordered from the chemical supply company. So your goal is to create the models. You're going to use the atoms in the before space to determine whether or not each suspect's substances could have produced the acid. If you think a suspect could produce the acid, draw the atomic scale model of the hydrofluoric acid in the after space. If there are enough atoms, draw more than one repeating group. So you want to use all of the atoms given. Also, draw any other atoms that were involved in this chemical reaction. Copy and paste the atoms in the key to create your model. If you think a suspect could not produce the hydrofluoric acid, write an explanation of why this is the case in the after space. In the before space, you've been provided with the atomic scale models of each suspect's substances. These atomic scale models are also provided in the substance reference guide. So here are all the chemicals that were purchased by each of those people. Okay, so these are the things that were purchased at the supply store. First up, we have Pat. Here's what Pat purchased: sulfuric acid and calcium fluoride. Could Pat have made hydrogen or made our acid? Do you think Pat could have made our acid? What do you think, Nathan?
Yes,
How come?
because you have the hydrogen in the sulfuric acid and the fluoride in the calcium fluoride.
Awesome job. And how many models could we make given the atoms that we have here?
I think we a total of 3. Well, 2.
Right, you can make up 2. So all you're going to do is click the H, and you're going to copy and paste. And you can paste that twice because you're going to need 2 of them. If you prefer to make your own atoms, have at it. I just thought this would be quicker and easier for you. And then, of course, we need the Fs. So we have the 2 hydrogens from the sulfuric acid and the 2 Fs from the fluoride. Again, we're going to copy and paste 2 of those. Just click paste twice, and you'll get 2 of them. All right, so Pat is a suspect. So go ahead and look at Alex and Tracy. If one of them you don't believe could have produced the acid, you're going to select a text box, and in this after space, you're going to give your explanation of why that person could not have created the acid. And when you are done, we are turning that in, I believe. Yes, you should turn that in when you are done, and then come back to the Nearpod. I will come around and see how you're doing. When you're finished, you should turn that in and come back to our Nearpod. We're just about done. So the substances that Pat and Tracy ordered contain hydrogen and fluorine atoms. So it is possible that either suspect could have made hydrofluoric acid with a chemical reaction. So we say that it is possible because remember, all of those atoms have to be able to rearrange into something new, right? And Sky pointed out to me that in both of those we have extras, right? In the bottom we have extra oxygens, and on the top we had extra, I think, sulfur and oxygens. So those also have to be able to rearrange into something in order for a chemical reaction to occur, because all of the atoms have to be used. We cannot create or destroy atoms. But at this point, just based on what they purchased and the atoms that are in those substances, both Pat and Tracy could have made the hydrofluoric acid. So at this point, Alex is no longer a suspect. Okay, we have those two suspects. So neither of the substances that Alex ordered contained the fluorine atoms, so a chemical reaction of these substances could not have produced hydrofluoric acid. And you should have explained that, saying that it doesn't have the hydrogen or the fluorine necessary to make it. You will need your completed model for the next lesson, where you will examine evidence that will help you figure out who stole the diamond. So tomorrow's lesson, you will be provided with another set of slides in which you will need to annotate them and then sort them. So you will be looking at, or I think it's just annotating actually, you'll sort on Monday, and you'll be looking at evidence, further evidence given to you so that you can start to decide whether you think it's Pat or Tracy that stole the diamond. Okay, questions? All right, make sure everything is handed in. And we are done with lesson 11.